Imagine you have a magic wand and you can basically know anything you possibly want about your system, and you can know it in real time. We also say we measure the unmeasurable. How these simulation models can also be used beyond the design and engineering lifecycle phases.
What would happen if people do not try to adopt artificial intelligence?
At the beginning, I would say it's missed opportunity, but with time, it's really turning into a lack of competitiveness. Misconception is that a lot of companies think that they can do it themselves.
All right, super excited for this one, Leoluca. Welcome to the show. Today we'll talk about the paradigm shift of something new. I know it's again a buzzword, Executable Digital Twins, short XDT. And some of the listeners might know it already. Digital twins, which we all know started as kind of a virtual representation of physical assets, mainly used in design and simulation. So everyone who's been dealing with design and simulation probably heard the term before. Now we have a new buzzword, named it Executable Digital Twin. And now Leoluca will tell us a little bit more about that. But before we jump into that, Leoluca, tell us a little bit about yourself, your background, and your work at Siemens.
Yeah, so first of all, thank you very much for having me. Really excited to join this podcast. So I'm in Siemens since many years, and I've did different roles in the organization. So my background is technical. So I worked as part of the research team in reduced order modeling. I also did my PhD and then kind of moved more into product management. I mainly look at new products, new initiatives, and how we bring them to the market. And so with the Executable Digital Twin, I'm responsible as a product manager globally to bring this new concept, this paradigm shift to the market. So this is mainly the focus area that I have today.
Got it. Interesting. Let's play a little bit Richard Feynman right now. Let's try to explain executable digital twins in very simple terms, as if you would explain to a 5-year-old.
Yeah. All right. So as you said, we are familiar with the digital twin concept, right? So simulating the real world in a digital environment, in a virtual environment. What we do with the executable digital twin is that we bring this virtual representation as part of the physical product. So for a 5-year-old kid would be like, imagine you have a magic wand and you can basically know anything you possibly want about your system, and you can know it in real time. So this is what we do with the executable digital twin. We also say we measure the unmeasurable, right?
Yeah, I see. What is then the delta? Well, what's the difference between the actual digital twin and what is the executable bit? What does it actually mean?
Yeah. So executable means that it can be leveraged outside of the simulation environment. So, usually simulation models and digital twins are always available in a simulation environment. And instead we package this virtual representation in a self-contained asset. So you have the model, the solver, and everything. And then we deploy this model as part of the physical product. And in that way, let's say to use this information, you don't need to be a simulation expert, but this information can be available for anyone at any point of the product life cycle.
Got it. Do you have some use cases that you can talk about in terms of like engineering, of course, and then also maybe manufacturing?
Yeah, exactly. So obviously we work with a lot of customers because to let's say develop and implement this concept. A recent one I can talk about is with the BASF in Antwerp, in Belgium, where they have this huge plant. I think it's huge, like many square kilometers of this chemical plant, right? Where basically they provide the services to different companies. So they have steam networks and the cooling network are the two most important ones. And the challenge they have is that they have like thousands of kilometers of pipelines, and they cannot know the status of like the water and the steam at each point of this pipeline. A lot of them, they run underground, so they also cannot just instrument them. But let's say how the flow goes into this pipeline is critical for, let's say, the day-to-day operations. And so what they developed is basically a full model of the entire plant. And then basically this model is running with the live data coming from the existing sensors. And using this model, they can virtually measure the flow, the temperature, and anything they want about the plant in real time. And so this gives the operators a holistic view on how the entire system is performing.
How then, from an engineering point of view, does this change the traditional life cycle when we talk about product development?
Yeah, so that's a very good point. So typically we talk a lot about the shift left strategy. So how simulation can be used to accelerate the product development, and that we also do it with executable digital twin in the form of model-based system testing, for example. What is really new is what we call the shift right strategy. So how these simulation models can also be used beyond the design and engineering life cycle phases. Because so historically, the simulation models were kind of confined in the CAE teams on the simulation experts. And now with executable digital twins, these simulation models can also be leveraged by automation engineers, maintenance engineers, operators, anyone that can benefit from this technology.
Yeah. Usually, Leoluca, when we talk about the benefits, I mean, every simulation company talks about this, like time to market, better decision making, etc. Like especially if you work in marketing, you've heard that before, right?
Yeah.
What is the actual benefit now of the executable digital twins?
Yeah. So first of all, so the benefit in terms of really, as you said, like return on investment, it's mainly about the minimizing of downtimes. So if you can have a better understanding on how your system is performing, obviously you can detect potential failures earlier, and so be more proactive instead of reactive. That is one, but you can also do one step forward, right? Because as you have your virtual representation, you can also make run, let's say, forward in time, and so really do what is called prescriptive maintenance. So you can say, okay, how should I operate my system such that I can meet the maintenance date without risking earlier failures. So that is one. Then there is the topic of, obviously, that also ties to sustainability, but energy efficiency. So as you know how your system is performing, you can obviously optimize the energy that is used. So you can make it run with the least amount of energy possible, which in the end is good for the environment, but it is also good for all the operating cost of the system. And then there is all the topic about asset monitoring. So really monitoring how your systems are performing. So these are the main areas where we see value on the executable digital twin.
If you think about it downstream or maybe like upstream, the second and third order effects on manufacturers, the suppliers, and the service providers, like how would they benefit from XDTs?
Yeah, so service providers, obviously, they can provide additional services. So these are, let's say, new ways to digitalize the real system. So service providers can obviously provide a higher efficiency with the executable digital twin. And for manufacturers, obviously, there is the topic of, for example, a higher quality. So if they can monitor in a better way the manufacturing process, then they can ensure a higher quality, less rejected parts, and then also improve what they call the overall equipment effectiveness. No, right? So the OEE can be drastically improved.
Mm-hmm. When we adopt new technologies, especially like let's say we talk about AI, right, or reduced auto models, I think in the business context we also have to ask the question: how do you roll out such a solution, right? So how can people or organizations adopt XDTs? Maybe you have kind of a little roadmap for them.
Yeah, so there is not a single way. So typically we start by assessing where they are in their digitalization journey. So there are companies that are already that have a very developed digital twins, that have very developed digital twins inside the organizations. And so in that case, typically we can help them do the step towards the executable digital twin. So we provide the tools. If they need, we can also provide the services to do it, to transform those digital twin models into executable digital twins, right? And so that's basically extending from design and engineering into operations. For companies instead that they're not that far ahead in the digitalization journey, then typically we focus on one to few use cases such that they can, let's say, start getting their hands dirty with the concept and develop it themselves. Or, as always, we can also provide services to support this concept and implementation of this concept.
When we talk about the data consistency and some other key requirements that at least so that you get the fundamental things right in an organization, what do organizations have to think about when they want to adapt XDTs, like data consistency, security, etc.?
Yeah. So typically, when it comes to let's say, the digital twin part, so typically we break down the process into digital twin authoring process, which is how you transform the digital twin into an executable digital twin, and then deployment, which is how you embed it on the physical product, and then leverage, so how you operate it. Each step has a different data are used, and let's say the most critical part for data consistency and security is mainly on the operation side. And so that's where we typically work, for example, with our automation unit, right? Because they provide the full edge and PLC infrastructure that is already that guarantees already the data security requirements. And when it comes to data consistency, obviously, as you rely on let's say an automation infrastructure, there is already available all the connectivity to the different type of data or the different data standards. So, for example, we work a lot with OPC UA, MQTT, all the data standards for operations.
Okay, now once we implemented executable digital twins, how do you actually measure success, Leoluca? Like, is it like maybe there's some specific KPIs that you measure, right? Collaboration between teams. I'm not sure if you can capture them in a couple of KPIs.
Yeah, so the collaboration between teams is obviously an important point because the digital twin comes from the design teams and then it somehow needs to go into the operations team. So that's for sure something that is crucial to the success. And so that's something that we can also help companies to work on it. When it comes to practical, really KPIs, typically we measure in terms of increasing productivity, reduction in downtimes, reduction in OPEX, for example. So these are all KPIs that we look after, and that depends greatly on the industry, the use case, but also what is the goal of the specific customer.
What role does AI play in this whole topic of XDTs?
Yeah, so AI plays, I would say, a very important role. So we use a lot of AI in the executable digital twin because the let's say the place where we use AI is, okay, how do you get to the executable digital twin? So this model has to be very lightweight, has to be very portable, has to be able to run in real time with live data. And so that's where AI is helping us leverage, for example, existing data from companies or also data from simulation, because through AI, we can take this data and basically create what we call a data-driven model out of it. And that model basically will contain all the knowledge, right? Depending on which data you give to the model. So it can be, again, simulation data or historical data from operation. Through AI, we can condense that knowledge into a lightweight and real-time capable model. So that is part of the creation process. And then obviously we can also use AI more in the leverage phase. So how the data from the executable digital twin are used. And there we have few pilots on how we can use, for example, large language models to basically interpret this data, right? To make sense of this data. So these are the two main areas where we see the use of AI methodologies.
Are you also experimenting or working on agentic systems for these types of applications? Yeah. How far are you? I mean, I'm not sure if you can talk about it, but it would be interesting to know.
Yeah, so I cannot give you great details, but we have few work streams on that go in that direction, and especially to streamline and simplify the creation process, right? So because in the end, our goal is to enable more and more people to be able to leverage this concept. And so agentic AI can really help in the creation process of the executable digital twins that sometimes can be complex depending on the background of the end user.
Mm-hmm. Interesting. Yeah. There's this saying of, let me try to get it right. Like, AI isn't scary, but not using AI is scary. Something along those lines. So the question is, what would happen if people do not try to adopt artificial intelligence or executable digital twins? Like, what would be the worst case if they don't adapt these solutions?
So at the beginning, I would say is a missed opportunity, right? But with time, it's really turning into a lack of competitiveness, right? So this is new technologies that are coming up and are proving to be very effective in solving some problems that exist since many years. And so being early in that curve is very important to then be able to really scale it and gain competitive advantage. It's like it's the same with any technology, right? I mean, also if we look, I don't know, emails, I don't know, something very, very simple, right? Maybe at the beginning, somebody said, okay, do I really need emails? I don't know. But then over time, you cannot really live without it, right? So, but it's also how these technologies become more mature and more, let's say, applicable to the everyday problems. That is also a very important journey. So how we can make them available to the end user.
Yeah. What do you think, Leoluca, will be the impact of XDTs and how will they evolve in the coming, let's say, 3, 5, or even 10 years?
Yeah, so it's. I think it will have a similar. Will follow a similar pattern as simulation, right? So simulation in general, if you look at the history of, for example, finite element models or CFD, it at the beginning was a very niche technology that was used, right, for few expert users, if we want. Over time, it basically spread, and now I think you would hardly find a company an engineering company that doesn't use some kind of simulation. And so as simulation has been, like say, established in the design and engineering, the same will happen also in operations and manufacturing, where the digitalization journey is just starting. And so if I look in 10 or 15 years, I would imagine that each physical system, each production machine will have the virtual counterpart running in the background live. And because in the end, that's natural thing, right? Is the real world and the digital world that are basically connecting, right? And they can live together to basically take the best of both worlds.
What do you think are some of the biggest misconceptions when we talk about digital twins? Because I think a lot of people define it differently, but
Yeah.
what do you think are some of the top 3 misconceptions about digital twins?
So the top 3 misconceptions. So I think one misconception that I often get is that they are complex, right? Because we always see like the fancy stuff, right? You always see like very complex CFD with vortices and all these things. But it doesn't have to be that way. So in some industries, it makes sense. In other industries and other applications, can also be very simple. Can also be a lumped parameter model or a mechatronic model, which can serve the purpose. So it doesn't have to be complex, right? And it's the same with executable digital twin. Sometimes something very simple can be very effective. The second, I think, is that misconception is that a lot of companies think that they can do it themselves, right? So they can build their own, let's say, models in some coding language or using some open source libraries, which is true maybe at the beginning. But what we saw also with executable digital twin is that as you scale within an enterprise, that to reach that scalability, you need basically to partner with a software house. And that's where we as SimCenter, as Siemens come into play to really give that those tools and capabilities that are scalable into an enterprise. And the third is probably that takes a long time to see a business return, right? A return on investment. That is also not true in general, because what we experienced with executable digital twin is that typically the return on investment can be very quick. So in some cases, we talk about like 4 to 5 months return on investment, which is extremely short. Also, because after that, you're basically gaining, right? You recovered your investment and you're gaining. So I would say these three are the main misconceptions that I see for digital twins and also executable digital twins.
Yeah, nice. Thanks, Leoluca. One question about like for C-level executives or like for leaders listening to this podcast. What should they do right now to leverage XDTs?
So first they should think about not the technological part, but the process part. So how this can transform their processes, right? How this can, again, the use case is good, is nice. I mean, you can drive value out of it, of course, but the real revolution is in the processes. So, and the process meaning that you are maximizing the use of simulation models that probably are already existing within the company, and you're basically bringing them into a new space where they can drive more value with a very limited additional investment. So what I would suggest is to look at the processes and how XDT can bring design and manufacturing and operations closer to each other, and then how they can, let's say, drive value from an horizontal collaboration within the enterprise.
So we talked about some of the foundations to get right when we talk about executable digital twins. Some other boundary conditions basically to get it right. So let's say someone now watches the podcast, or like they are convinced they need XDTs, right? What are some of the pitfalls when you start with XDTs that you absolutely want to avoid? Like you already adopted it, right? What can you do wrong right now where it would actually backfire in the worst case?
Yeah, so I would say my advice would be to start small. So it's sometimes with new concepts or new technology, users basically throw at it like the most complex problems, right? And that's typically not the best way to do it, because you want to start from something simple, get some quick wins, and then grow within the concept, right? So really learn how to do it right, and how to scale it. So my recommendation is always identify the lowest hanging fruit, right? So the problem that you are confident you can solve it with XDT, and that brings value and a quick return for the organization. And then from there, you can grow into more complex and more articulated applications.
Mm-hmm. That's great. I mean, did we miss anything, Leoluca, in today's podcast? Is there something that I haven't asked you that I should have asked? I think we pretty much covered everything.
I think we covered pretty much everything.
Yeah, unless you have something that's missing, maybe some last advice to all the listeners.
That's more a general advice, right? Be curious. So don't be afraid of trying out these new technologies, because maybe you have the feeling or you think they are complex. Because if you choose the right partner, I can guarantee that can be very easily implemented, and we can turn problems into quick wins quite easily.
Great. So we'll leave it at that. Leoluca, thank you so much. If you have any other material or something that you can share with the audience, I will link it down in the description.
Yeah.
And yeah, we'll leave it at that. I learned a lot, certainly in this podcast, and thank you so much for being on the show today.
Thank you very much for having me.
Appreciate it.